this. Okay. Morning, Joshi.
Morning.
Okay. So here it is. And I lost it again. How can I move it? Okay, I'm not moving it. That's fine. I don't care. Be that way. Okay. So we need to have our table in place, right? So table, and we need a 3 by whatever. I want it white. So are you copying the circuit in the meantime? By any chance? Okay, there. Then I want it completely white, but with stuff in there. Yes. Okay, I'm becoming good at this. Not that much because I have one extra column. How do I remove?
It's at the top. When you're on it, when you're clicking on it, there's okay, never mind.
What?
When you click on the gray, there's an option to cut at the top.
Where? I
Try
did.
to get rid of it.
Oh, God, I can just. Ooh, I didn't know. Okay, so forget about the fact that I'm getting better at this. Okay. So you have the V, R, and I. So let this one R1, R2, R3, R4, and R5. And let's say that this is 18 volts. Okay. And let's give a numbers. Let's say 3 ohms, 2 ohms, 5 ohms, 1 ohm, and 4 ohms. Okay, so this is your V equivalent, 18 volts. And at this point, who can take over? Joshi, do you think you can do it?
I'd have to go grab my notebook real quick, and I could try.
Mm-hmm.
All right. Give me a sec. I mean, I don't have it done yet, so.
Ben, can you do it?
Me?
Mm-hmm.
No.
David, can you do it?
I can start it, but I can't really draw very well, so.
So who Connor, can you do it?
Oh my God.
My bad, I was grabbing a piece of paper. What?
I mean,
Hello?
do it on paper and you can show me what you did afterward.
No, I was grabbing one. I didn't hear what you said.
Can you solve this circuit?
Not fully. No, I don't think so.
Did you watch the video?
No, not yet.
Oh,
I'm sorry.
Come on, you're home. You're not doing anything any day, right? So
I know.
you got to start from here. I don't want to hear it. So
Do you combine 1, 2, and 3, and then combine 4 and 5?
No.
who said it? Yeah, Charlie.
Okay.
Can you do it?
I mean, I can. You're gonna have to blow up the screen a little bit though, because I can't write that small with my finger.
Then I don't know how big you're seeing it. I'm seeing it pretty big. Top of this.
Okay, that should be good. Okay. So then,
Okay, Charlie, stop. So no.
what?
No. So let's do it together first, okay?
Got it.
Okay.
So
First, you have to split it up.
yep. So you got to follow the current first of all, okay? So you have the current that is going through this branch, through this resistance, right? And this one that is going here. Then this one is a different type of current, right? Because the current is going to 3. Some goes into R2, some goes into R4, right? Then I don't. If I would just know how to remove the stuff that I'm seeing. Oh, X. Okay, so this green is also going. Okay, it should be green. I don't know why it changed color. Okay, and it's going around. So it's not changing, right? It's not branching off. So what does this tell me about R4 and R5?
You can combine them
Yes,
when talking about their amps.
exactly. So I have to redraw the circuit a lot of times, okay, until I get down to only one resistance. So this is still staying. So this is R1, this is still R3, this is R2, but R4 and R5, I can combine them because those are in series, because they are crossed by the same current, right? So this, I can write a unique resistance, which is R, is not 4, is not 5, is 4, 5. Okay, so this value is now 5 ohms because I have a 1 plus 4 is 5 ohms, right? Then
Yeah.
okay, R2 instead is 2 ohms, right? So I got to redo the whole thing again.
Missy.
Yeah.
Jack Donovan said he's been trying to join, but he can't for some reason.
Oh, okay. Oh, what? No,
Oh,
no, what are you doing?
what the?
Okay, so the current is going here, okay, and here is branching, right? So I don't know why I can't choose any color. Okay, so some is here, some is here, right? So what is this telling us about R2 and R4, 5? That those two are actually in parallel, right? So this is your circuit again. So you got R1 here, R3 here, And this one, I can replace it with a R245. Make sense? So
Yep.
two are in parallel. So R2 is 1 over 2, right? And R45 is 5, 1 over 5. I got to do the 1 over this. So this will give me this resistance here. So this will be the 2R245. Okay? How much would that be? So 2 over, enter, over. So this is 1.43. Okay, so this is 1.43 ohms. Okay? So now I have those three. So imagine the current again. Guys, if you don't draw the current, nobody can tell you in which relationship every resistor is, okay? So now the current does not branch off. So this means that those three resistors are in series. So I can find the total equivalent resistance as adding R1, which is 3, R3, which is 5, and R245, which is 1.43. Okay, so this will be 9.43 ohms. Okay, so 9.43 ohms goes right there. Okay, so at this point, every single time you have two things, you can solve for the third. Okay, so I can calculate I equivalent because I have 18 as volts. Okay, divided by 9.43 as ohms, and I have a 1.91 as amps. Okay, if this is the I equivalent, then this is the I equivalent. 1.91 amps is the current coming out from the battery and crossing R3. Okay, then you pay attention to what you said. Did I just crossing R3? So this means this is I3. Is crossing R3, and then at the end, this current will go back here, right? Crossing R4 well. You okay?
My bad.
So I1 is also 1.91 amps. Okay, so for 1 and for 3, I have two things. I can calculate the third, right? So if I multiply 3 times 1.91, I get a 5.73. So this is V1, 5.73 volts. Okay, for this one instead, 5 times 1.91, I have a 5, what I have? 9.55. So V3 is 9.55 volts. Okay, now would be nice also to go there and to start drawing what those volts mean. So this is V1, which means if I take those probes, those wires, and I connect the voltmeter there, 5.73 volts. And those are the volts used from 18 volts, right? So out of those 18 volts, I'm using 5.73 for powering up basically R1, and then V3 instead is the voltage that I will read across R3. So this is the 9.55, which again are volts chewed off the 18. So if I am using this much volts and this much volts because of these two factors, how many volts across R2? Any idea?
Would you add 9.55 and 5.73 and subtract it from 18?
Yes, perfect, awesome. So 18, I remove the 7 point whatever the number is, and I remove 9.55, and I should have a 2.72. True? So 2.72 is across this resistor R2, which means I can go here again and I can write V2 as a 2.73 volts. I got two things. I can solve for the third one. So 2.73 divided by 2 is 1.36. So those are the amps here. So I2 is 1.36 amps, right? So now, how much current do I have across R4? So across R2, we have a 1.36, true?
Well, isn't it going to be 1.36 for R5 too? Because they're parallel.
Say it again?
Isn't R5 going to be 1.36?
Not anymore, because I have this one also that is chewing voltage away. Okay, so 1.36 is the current going through here, but I was starting with 191. So how much current I have here?
You'd have the difference between 1.91 and 1.36, like 0.5 something, 5.7
0.5?
or 0.67. I think it's 5.7.
5.7?
Yeah.
Okay, so this means now you can say that this 0.57 is the current across R4, and because those two are in series, is also the one across R5. Okay, so this is I4 and I5. Then I have two things I can solve for the third. And now I'm done. Is making sense, guys? And again, at this point, every circuit is different. It's not just copy and paste like before.
And
Okay.
that was a little, I was off by 0.2. It was 0.55. I apologize.
Oh, okay. Perfect. Okay. So this voltage here is going to be the product between those two, so 0.55 volts. And this is 0.55 times 4, which is 2.2. Okay? So how is it looking?
Wait, so how did you find the current of the first one?
I got to solve for equivalent resistance first, and then I have to do the division between voltage and resistance. So once I have the I equivalent, 19.9,
Okay.
I know that that's the one that is coming out from the battery. Unless I branch, the current stays. So you really have to follow and keep on drawing the circuit over and over. And the last one. Make sense, guys, a little bit?
Yeah, just the last two currents that are 0.55 is the reason that R5 is also 0.55 because they're like a series.
Yes.
Okay.
Yes. Very good. Can we do another one?
Yeah.
Okay, so what's this? Okay. So let's do, okay, let's start like before. You have a resistor here, another one here, another one here. Yeah, let's leave it like that. And then, okay, so let's complicate it just a little bit, but it's basically like before, okay? So let's give this one a 20 volts. So this is R1, R2, R3, R4, R5, R6, R7. And insert. So, and let's see how many we need. Okay. So this is VRI. Okay, so for R1, let's give it a 2 ohms. For R2, let's give it a 3. R3, let's give it a 1. R4, 5, dot more. R6, R7, and I have no space for the, can we put it on top the other equivalent, guys?
Yep.
Okay. So this is 2 also, this is 4, this is 1, and this, I mean, at this point, I can only, keeping them integers doesn't mean much anymore. But let's do this one as a 5 ohms, okay? Okay, so your V equivalent is the 20 volts. So do you think you can take charge or not yet? For me to go through it again?
Oh, Missy, I think I could do it.
Yay! Go for it.
Okay, you want me to write on there?
Yeah, you can. Yep.
Okay. So,
And make it big.
yeah.
Is that big to you?
Yeah.
Okay.
So first you make the, or actually wait. Yeah. First you make the other one.
Mhm.
And then you do, and that's like, this is our, and then this is our, it's too high at the top. I can't. This is the R1 and R2 on the top. Then this is R7. And this is R3 right here. And then this over here is R4, 5, and 6. And then you make another one.
Have you ever thought about being an artist?
And then this.
Volunteered. You didn't even do that.
This is R3, R4. Oh wait, R4, 5, 6 is I didn't write that down. How many ohms is R4?
R4 is 2.
2 ohms. 4.
R5 is 4, and R6 is 1.
Okay, so then that's. Can I write it all down on my notebook and then
Yes,
do it?
do them. Yeah.
Okay.
What happened to the R1, R2?
I couldn't write it.
Oh, okay.
It's too high on my screen.
Oh.
So then R456 would be 7 ohms,
Mm-hmm.
and then you make another circuit with R1 and R2 on top, and then R3, 4, 5, 6 on the side, and that would be 1/1 plus 7.
1/7.
1/7, yeah. Which would be, that would come out to be 0.8 0.86 ohms,
Okay.
and then you add that to R1, 2, and 7.
Perfect. Awesome.
So that would be point 0.88. I mean.
Yeah.
So then that would be the R equivalent would be 10.88
Perfect.
ohms.
Fantastic. Yes. Is everybody
And then,
the same, guy? So you said 10.88
yeah,
ohms is your equivalent resistance. Yes, perfect.
and then you divide 20 divided by 10.88 to get 1.84 amps.
Yes.
And then that would be, because the current goes through R7 and R1 and 2, it would be that would be the same for R1, R2, and R7. So they would all be 1.84.
Perfect. Yes. Now what?
And then you multiply R the ohms of R1 times the amps of R1,
Yes.
and do the same for R2 and R7
Mm-hmm.
to get the voltage.
So this is the 368, right?
Yeah.
And this?
5.52,
Yes. Awesome.
and then and then 9.2 for
Now,
7.
that's
And then you add those all together and subtract it by 20.
yes. Perfect. Because so across this one, right? You said you have a 9.2 volts, right? Across
Yes.
this one, you said you have a 368 volts. Across this one, you have 5.52 volts. So that's why you're adding. Perfect.
And then that comes out to 1.6 volts for R3.
Nice. So across this one is 1.6.
And then you use that to find the amps. So you divide 1.6 divided by 1, which is 1.6.
Yes. So this is 1.6. This current here used to be 1.84. So how much you have here?
0.24 amps.
Yes. Which is
And that's,
across everyone, right?
yeah.
I'm sorry, so this is 1.6, so 0.24, 0.24, and 0.24. Yes, and now you can calculate those voltages, right?
Yeah.
0.48, how much is this?
Mrs. C, I have a question.
Yeah.
Should all the like voltages at the end equal the like equivalent voltage of 20 or no?
No.
No? Okay.
All those, so all the parallel have to have the same voltage, right? Because imagine that you have 3 parallels of 10 volts each, right? And the battery gave you 10 volts. So if you're adding those, you will have 30 instead, right?
Okay.
So if you add the voltages, if you do, for example, the 20 that is here, and you remove 1.6, then yes, all those voltages inside this loop have to end up to whatever number you have. So what is this, 18.4? So all of those should be 18.4. So do we have it? So the last one is 4 times 0.24 is the one that we need. So 0.96 and you're done. So what do you think? Is making more sense a little bit, guys? Drew, awesome job.
Thank you.
Yep. Can we do another one? And then I assign you homework?
Could you do one, Miss C? Like, could you do one?
Yeah. So if I can change the slide, okay. So let's do another one, and let's say you have this one here, here. Let's do 2 here.
It's almost done. Yeah, I know.
And let's do another one here. Okay? So R1, R2, R3. Ben, you gotta do it also though, okay? Otherwise you cannot just learn it.
Huh? No, I'm doing it.
No, probably not. Gotta make my coffee now.
Okay, so those are your R's, B, I. So let's do this one 18 volts. Okay, so one, let's say, is R2 is 2 ohms. R3, let's do it very bluntly. Okay, 3, 4, 5, okay, 6, and R7, we call it then. The other numbers, we would. Okay, so the equivalent, let's put it here because I don't have space. Okay, so you're starting with 18 volts. What's going on in this case? So current coming from the battery comes out there, goes here, and switches off, right? So you have some current here, some instead is going across. Then this one branches again, is here, and some goes here, right? Then green and orange join again together to form this brownish thing, and then this and violet there give you the red again. Okay, so by looking at those colors, you should see what kind of circuitry are you having. So start from the last. Those two are in parallel because the currents are different, right? So if they are in parallel, then you have the first circuit that looks like this. So you have R1 still in place, R2 and 3, guys, from here you see that those are crossed already by the same current. So I can replace right away if I wanted to. I don't have to wait. Make sense? So this is going to be R2 and 3 series, right? And as 2 and 3 is 5. So this is 5 ohms. I know that it makes sense. Then this one is the 7. I can't touch it right now. Okay, this is the 4. Can't touch it right now. But those two are in parallel. Okay, so this is your R, 5 and 6. 5 and 6 is 6 ohms and 7 ohms. So this is going to be the 6 over and the 7 over, enter over. So this 3.2. So this is 0.23. Okay, so then going to the current, and you're going here, thumb here, thumb goes all across. So all of those are in series. So 7 and 4, and this one are in series. 7 is 7 ohms. 4 is 4 ohms. So this is 11 plus 3 is 14.23, right? So this one stays, this one stays, this one stays, and this one we said is, what did I say, 11? 14.
Ivan says.
This is 7, and 4 is 11. So 14, right? 14.23 is this one. This is 5 ohms instead. This is R1, which is 1, and this is nothing. Oh, there's no resistance here.
Let's see. How'd you get the 14.23? You added
Added this, and this, and
the
this.
4. Okay. Yeah.
Wait, how did you get the 3.23?
Because I put together the 5 and 6. 5 and 6 are parallel.
Is that the inverse, right? The inverse adding.
Unless I clicked the wrong number. Did I
Yeah,
use
I got
so I
0.73
What?
for that.
I got like 2.72 or
Like
something.
11?
Yeah, because I think I put a 7 there, right? So 5 inverse and 6 inverse 2.7.
Yeah.
Okay.
So this is now 2.73
What?
11. So this is 13.73.
Like 4?
Am I right?
Yeah.
Okay. Then one more step. So two are in parallel because the current goes here and break, right? So this is 1 over 5 and 1 over 3.73. 5 over and 13 over, this is 3.67. Okay, so I have the circuit here with this resistance here, one instead. It's a parallel between those. Okay, so this is 3.67. Okay, now those two are in series. I can add them up. Fine. I have found the equivalent resistance. Okay, so this is the 4.67. Right here. Make sense? Now at this point it's just like, right? 18 divided by 4.66. This is 3.85. Okay, and I can start assigning those currents wherever they belong. Is making sense, guys?
Kind of.
I kind of got lost where you made that circuit with the 1 and the 3.67.
This one?
Yeah, I don't know how you made that circuit.
The 3 is coming here. I have one parallel here, one parallel here. So I'm doing 1/5 and 1/13.7. And I get
Oh. Oh, okay.
and then at that point start assigning stuff. So the current is coming out from the battery with 3.85. So red is 3.85. So this one is 3.85. So you can calculate the voltage across R1. So this, the V1 is 3.85. Across here, I'm losing 3.85. How much do I have across both of those? Watch out.
$14.08 or no, 7.08
Exactly.
per volt.
Yeah, 14 point, I guess 14.50. Am I right? But anyway, if those voltages across the both resistors, I can calculate this purple current, right? But not the voltage across R2 or across R3. I know the voltages across both resistors. True? Is making sense, guys?
Yeah.
Yeah.
Okay. So if this is 14.15, how much is the current that is going across R2 and R3? And guys, the bell is rung, so I can finish it off and send you the video. I can repeat a couple of more circuits. Guys, I'm confused because I keep on hearing parents talking.
Yeah, I keep hearing stuff in the background too. I can't hear.
Confused. So I'll send you the homework and I'll solve it also and send it to you. Okay?
Okay.
Thank you, Mr. C.
Thank you.
When will that be due?
Say it again?
Thank you.
Is that due tonight?
Yes.
Okay.
Okay.
Thank you.
Bye, guys.
Bye, Mrs. C.
Bye.